Assalamu alaikum, dear students. I hope that everyone is doing well. We have to continue with Unit 5, Sets and Functions, and for today the topic is binary relation. Dear students, before proceeding towards the topic, let's have a word of appreciation for the students who have given presentation. The first name here is of Imran with outstanding presentation, Asim Raza outstanding presentation, Ahad marvelous presentation, Faiq Abdullah marvelous presentation, Momina Harim excellent presentation, and Zoha Jabin outstanding presentation. It's the time to appreciate those students who have submitted their homework. So the first name here is of Saman Khalid with 5 stars, superb. Fatma Nadeem 5 stars, superb. Mehlal excellent. Sabrina Khan excellent. Iman Tanvir excellent. Zainab Salim excellent. Umayya Khan excellent. Maniha good. Anusha Saqib good. Ahad superb homework, Shahir excellent, Muhammad Shahzar excellent, Hussein Shah excellent, and Muhammad Hashim Ali excellent work. Dear students, in the previous class we learned about Cartesian product, that if we are interested to show the relation between the elements of the two sets, so that relation can be shown with the help of Cartesian product, and that relation is shown with the help of ordered pairs. So let's revise the Cartesian product. Cartesian product of two non-empty sets A and B denoted by A into B consists of all the ordered pairs x, y such that x belongs to A and y belongs to B. For example, we have set A which contains the elements x, y, z, and set B which contains the element 1, 2, 3. So if we are interested to show the relation between the elements of these two sets, so it can be shown with the help of Cartesian product A cross B. So let's have the maximum relation between the elements of these two sets. So x can be related. We can relate x with 1, x with 2, x with 3. Similarly, y with 1, y with 2, and y with 3. Then z with 1, z with 2, and z with 3. Here we have connected every element of set A with set B. So this is known as Cartesian product. Here we can see that we have 9 ordered pairs, 9 elements in the Cartesian product, because the number of elements in set A is 3 and number of elements in set B is 3, so 3 3s are 9. Okay, let's have the introduction of the today's topic.
What is a relation? A relation gives us a set of ordered pairs that satisfy a relationship. Let's understand this using an example of two sets. We have two sets P and Q. Set P has elements 2 and 4 and set Q has elements 10, 20 and 35. We first take the Cartesian product of the two sets. Let's use an arrow diagram for the Cartesian product of sets P and Q. So P cross Q is a set of the following ordered pairs. It's 2 paired with each of these 3 and then 4 paired with each of these 3. We get 6 ordered pairs of the form P, Q, where every P belongs to set P and every Q belongs to set Q. That's how it can be written in the set builder form. Now let's introduce a relation R. Relation R gives us a set of all ordered pairs that satisfy a relation. It could be any relation. Now, suppose we introduce a relation R' such that Q is a multiple of P. So we can say that relation R' gives us a set of all ordered pairs P, Q, where Q is the multiple of P. Every ordered pair in the set R' satisfies the relation R'. This is the set builder method to represent R'. Please note that Q has to be a multiple of P here. Now let's choose ordered pairs from a Cartesian product P cross Q that satisfies the relation R'. Look at the ordered pairs in the Cartesian product. Notice that 10 is a multiple of 2, 20 is a multiple of 2, and 20 is a multiple of 4. So we get the ordered pairs 2, 10, 2, 20, and 4, 20, such that every ordered pair satisfies the relation Q is a multiple of P. This is the roster method to represent set R'. Roster means list. So we can say that the ordered pairs in set draw one arrow for 2, 10, another arrow for 2, 20, and another arrow for 4, 20.
Let's here summarize the topic that if we have two sets P and Q, so the Cartesian product is a set which contains all the relations between the elements of these two sets, whereas the relation is a set which contains some specific relations between the elements of these two sets. So that relation can be any type of the relation. Sometimes the relation is given as here in the example that the relation is that Q is a multiple of P. So from the Cartesian product P cross Q, we are going to find such pairs where Q is the multiple of P. So that will be a relation between the elements of the two sets where Q is a multiple of P. So let's see in the Cartesian product that where Q is the multiple of P. We can multiple means that it comes in the table of that. So we can see that 10 is the multiple of 2, 20 is multiple of 2, and 35 is not multiple of 2, so that should be excluded. 10 is not a multiple of 4, so this pair should also be excluded. 20 is a multiple of 4, so this can be in the relation, and 35 is not multiple of 4, so this should also be excluded. So we have here in the relation 2 with 10, 2 with 20, and 4 with 20. So this is a specific relation where Q is a multiple of P. Or in other words, we can say that a relation or binary relation is the subset of the Cartesian product, which is shown with the help of these arrows as well.
Let's say this entire circle represents the set of elements in the Cartesian product P cross Q. In that case, set R dash will be a part of it. We can say that set R dash is a subset of the Cartesian product P cross Q. That's the basic concept of a relation. A relation gives us a set of ordered pairs that satisfy a relationship.
Okay, here we can conclude that relation is the subset of the Cartesian product because relation is a set which is derived from the Cartesian product. Here we have the binary relation that if A and B are two non-empty sets, that a subset R, this is a symbol for the subset that R means R is stands for relation. R is the subset of the Cartesian product is called the binary relation. Means binary relation is that set which is the subset of the Cartesian product from set A into set B, because there exists some relationship between the first and the second element of each ordered pair in R. Therefore, it is named as relation, binary relation. Binary means two because there are two numbers in the ordered pairs. For example, we have set A here which contains two elements 2 and 3, and we have set B here which contains two elements 4 and 6. And we are going to form a relation. This R stands for relation. R means a relation from A to B such that this is x relates y such that y is double of 2x, means y is double of x. In this example, we are going to establish such relation where y is double of x. So we cannot find the relation until and unless the Cartesian product is met, because the set of Cartesian product consists of all the relations, whereas the set of relation consists of some specific relation which is given here as y should be double of x. So first of all, let's have the relation or the Cartesian product between the A and B sets. So 2 with 4, then 2 with 6, 3 with 4, and 3 with 6. Now from this set, we have to form a relation, or we have to establish a relation R where y is double of x. So here we can see that the first element is x and the second element is y. So we can see here that here y4 is double of 2. So this can be in the relation. 6 is not double of 2, so it should be excluded. Similarly, 4 is not double of 3, but 6 is double of 3, so this will be in the relation. So this is a relation.
functions, and there is a very high likelihood that you would see a question based on them. What is a domain? In simple words, the domain of a function is a set of all possible input values. And what is the range of a function? The range is a set of all possible output values. The domain is the set of all values that go into the function, and the range is the values that come out. So if we have a function like y is equal to f of x, the domain will be all possible values x can take, and the range will be all possible values for y. Is there any good way to remember this? How do we remember that the domain is all possible input values and the range is all possible output values? Maybe something like d comes before r and x comes before y. Domain is x and the range is y.
Here we have to learn about the domain and range of the sets, or domain and range of the relation. Suppose we have here y is a function of x. As we know that in a relation we have the ordered pairs, and in ordered pair we have x and y. So x is always the independent variable. You can put any values of x, then you can have the value of y. So here y is dependent. So therefore domain is all the possible input values and range is all the possible output values. Means all the means the first elements will be domain, which is x, and the second values, which is y, that will be range. Here we have domain and range of the relation. The domain of relation, denoted by dom R, is the set consisting of all the first elements of each ordered pair in the relation. For example, we have the relation 2 and 4 and 3 and 6. So what will be the domain? Domain will be all the first elements of the each ordered pair. So first element is 2 and the first element here is 3. So this is domain of the relation. Range of relation, denoted by range, is the set consisting of all the second elements of the each ordered pair in the relation. Here we can see that the second element is 4 and 6. So this will be the range of the relation. Here we are done with the introduction of the topic. This is all for today, and tomorrow we will start inshallah the exercise of this topic. Here is your today's assignment. You have to read page number 99 in order to revise the topic binary relation. Thank you, students. Stay blessed and have a nice day.